Now let's see what interesting differences that Rust has brought about with respect to bitwise operations. Here the right hand side is C code and left hand side is Rust code. So bitwise operations are very common when working with low level hardware, especially hardware registers. So in such code, there are many bit masks that are generally defined to check if a bit is set or if a bit is not set in a register or to reset a bit. So these are all very common operations. So let's now see only differences now. So let's focus only on these two blocks. On the right hand side, this symbol, the tilde symbol, is called bitwise NOT. So bitwise NOT basically takes care of flipping every bit of the integer. So every 0 becomes 1 and every 1 becomes 0. So this is primarily used when dealing with clearing bits or resetting bits. So in this case, A is equal to 3 and 0th bit is being reset. So bitwise NOT is represented using the tilde symbol. So in case of logical NOT, it's applied on booleans, and when applied on booleans, true becomes false and false becomes true, and it's represented using exclamatory symbol, and the result of these two operations are printed. So similarly, same logic is being followed on the Rust code. However, there is one big difference. So when performing bitwise NOT or when performing logical NOT, the same exclamatory operator is used in both the cases. So when applied on integers, it performs a bitwise NOT. When applied on booleans, it performs logical NOT. So how does Rust manage with just one symbol and two operations? However, why does C need two symbols to work on bitwise NOT and logical NOT? So this is because in case of C, implicit type conversions are very common. For example, bool may get promoted to integer. So the type of the variable, the user defined type, need not be retained. It may change over period of time. So this B in some cases might get promoted to integer, right? So because of which the type is, it cannot rely on the type to perform the operation. So however, in case of Rust protects type safety, means whatever the user has defined, that will not get changed throughout the program. There is no implicit type conversions at all. A bool will remain bool throughout the program. An integer will remain integer all throughout the program. It will not change. So because the type is fixed, the operator, the bitwise NOT, means the exclamatory mark applied on an integer, will always perform bitwise NOT, and when applied on boolean, it performs logical NOT. Okay, so here this symbol depends upon the type of the operand. So if the operand is integer, it performs bitwise NOT. If the operand is boolean, it performs logical NOT. So this is one of the major differences. Let's compile both the programs. This is C code performing different operations. So this is after a reset. So we reset the bit, 0th bit, right, and it prints 2. This is printed in binary form, and this is logical NOT. So similarly, let's see Rust 1, Rust code. Let's print it, and it prints the same values, right? 11, 0, 10 and false. So these two we saw.